Hello, welcome. I'm going to talk about synesthesia and its connection to childhood and psychedelia. So, uh, some of you might know this already, but one of my previous projects that people tended to like a lot was this idea called the Phoenix effect. It is basically the idea that children are psychedelic, that psychedelics induce the same state of mind that children are in. And this includes even the visual effects. I suspect that some of these visual effects and perceptual strangeness might be due to um, kind of a perceptual calibration of sorts. So today I'm going to be kind of reviewing one of my newer projects in which I've kind of found more evidence that could support this hypothesis or theory. So um, let us begin. It appears that synesthesia could be the basis of our experience of the world, though perhaps to different degrees in different people. Um, so people with synesthesia experience an overlap of the senses of some sort, uh, where you can imagine it's a crossing of the senses. So you may hear colors, or you may see sound. And one common form of this would be, I think, grapheme color synesthesia, where letters or words might be perceived as having a color associated to them. So, as an example, the letter A may conjure up the color, or no, the letter A would possibly conjure up the color red. So if you look at the color or the letter A on a piece of paper in your mind, you may see this as a red letter. And so what I believe is that this synesthesia may be what underlies perception in general. I think that the basis of our perception is multiple forms of synesthesia, especially probably more so in the case of the associative cortices of the brain. So in the brain, there's basically if you see something, it travels from your eyes to the primary visual cortex, and then there's a secondary visual cortex, and then it moves on to associative cortices, where that is where senses overlap. Basically, that is where you might associate more than one. It is where you'd kind of have the joining of different senses so that you can kind of, like, you might link together sound uh, and objects. Like, say something hits a wall, maybe you would associate the sound it makes with what you just saw or something like that. Um, so I would argue that when you think of the word dog and you pull up the image of a dog, I would say that this is a kind of synesthesia. Um, and so, this kind of synesthesia that I just described right now, that is one that may exist in generally almost everybody, unless you have some kind of brain damage that prevents that kind of associative processing from occurring. And I think that the reason this kind of synesthesia is normal as opposed to something like uh, the letter A and the color red, I think that this kind of synesthesia is essentially trained by our culture. So we teach our children to associate those, and we habituate that kind of associative processing. And so all of language may be kind of this synesthetic experience. And the letter A being associated to red might be that same kind of synesthesia in a sense, except that it is not taught by society, so therefore it is neglected. Most people then will not reinforce this kind of processing, and it will be pruned away once we undergo synaptic pruning in development. So synaptic pruning is essentially so you have synapses in the brain where that is like the space between neurons. You've probably heard of that before. So it is basically the connection to different neurons. And so when we are infants, everything is very much more hyper connected, and we prune away those connections so that there's essentially just less connections, and this is thought to be part of learning. So so for example, this letter A being red, you might originally associate this because of the word apple and how apples are red, let's say. And then the child learns later, it may not even necessarily learn this like by being taught, but they may realize that red is associated to a lot of things and that the letter is perhaps arbitrary and that it's not significant enough of an association, and it wasn't repeated enough that now they will kind of, that is one of the connections that dies as we go through synaptic pruning. And all the connections that are deemed insignificant or not legitimate enough or something like that might be pruned away. And then we are left only with very specific, specialized connections to different neurons in the brain. And so here's where it gets kind of interesting. The word red is associated with the color red. So that could be a form of synesthesia that is a word color association. It is just very specific, and we no longer kind of call this synesthesia. We just consider this normal. But the word red is just a random sound that we make. It is just a random sequence of symbols that we write, R, E, D. And if we were born into a different culture, that sound would not be associated to the color. And so if we never learned English and we were born into some other culture, if we heard the sound red and associated it to the color, that might be something like synesthesia, only because synesthesia is essentially being defined as the kind of synesthetic patterns that we aren't expected to have. But my argument is that all these connective patterns are synesthetic. And so I would argue that also animals undergo this kind of synesthetic experience too, except it's not with language, but some of them might do it with something like language. But take the sound of water, for example. You may hear the sound of water and you recognize this. You recognize that sound as being synesthetically associated with this liquid thing that you've come to know as water. And so I would argue that animals likely recognize the sound that water makes with what water is through their sense of vision, for example. And so there's something interesting. Let's move on now to brain differences between those who have synesthesia and those who seem not to have it. Except, so synesthesia in this case would be things like associating letters with colors or associating sounds with colors and things like that, or with shapes and different things like that. So those who have these kinds of synesthesias in adulthood, they have increased white matter tracts in the brain. And these white matter tracts are involved in connecting different regions to each other. And so this is kind of interesting because the argument would be that these are unpruned connections. And this kind of even ties into autism, which we'll get into in a little bit. We'll wait on that for now, though. So something that's interesting is the drugs that induce no, I shouldn't say that yet. The drugs that induce synesthesia are the psychedelics. And what's interesting is they induce synaptogenesis, which I would argue is the opposite of the opposite of synaptic pruning. Instead of culling away these synapses, we are experiencing a increase in the synapses, a restoration of lost or pruned synapses. And so psychedelics induce that. They induce synaptogenesis and they induce synesthesia. And some people get long-lasting synesthesia after the psychedelic drug has worn off. And this is where it starts to tie into this whole project, the Phoenix effects. Okay, so in the Phoenix effects, we've kind of covered about how psychedelics and infants both have enhanced functional connectivity, which is essentially that more parts of the brain start cross-talking compared to someone who is an adult who is not on psychedelics. Their brain is more disconnected. And there tends to be more like patterns of like very specific crosstalk that is I don't know how to say it other than like very specific, that it's very like sculpted and fine-tuned. But when people take the psychedelic, it's more chaotic, disorganized, and there's regions that don't usually talk. They're talking to each other. And so the idea might be that synesthesia is emerging because there's this crosstalk of different sensory regions that doesn't normally happen, or something like that. So what's interesting is that, so I've already mentioned infants have a less pruned brain because they haven't undergone synaptic pruning yet. More interesting is that there's been an argument by this researcher named Brogard. He's, I think, a Swedish researcher. I might be wrong. I should have maybe just not said it, but I'm pretty sure he's a Swedish researcher. And he argues that serotonin hyperactivity during development might bring on synesthesia. It's important to note, though, that part of his argument is that he brings up the psychedelic drugs inducing synesthesia. So I don't know. It's kind of important to note that. So it might be that synaptogenesis of these serotonin mechanisms. So I don't know if I mentioned it. Some of you probably already know this. The psychedelics I'm talking about are serotonin based psychedelics like LSD, psilocybin, things like that. And so these tend to induce synaptogenesis. So the idea might be that they are allowing for less pruning to occur, as if we had lower serotonin, that might allow more pruning to occur. And so there's this interesting argument that has become somewhat popular in the world of synesthesia research. It is called the Neonatal Synesthesia hypothesis, and it's originally put forth by Daphne Maurer and her colleagues. I probably said that wrong. So basically, the idea is that all infants are synesthetes, and that we lose this ability during development, but some retain it, and this becomes adult synesthesia. So the arguments basically involve the observation that there's increased connectivity during infancy, synaptic density is greatest soon after birth. There's with synaptic density is greatest in sensory cortical regions, or no. The sensory cortical regions have synaptic density that decreases towards adult levels earlier than in other regions. So these may be undergoing pruning faster than other regions. And let's see, checking over some notes. So in particular, there seems to be anatomical evidence of pathways from the auditory to visual cortex that are reduced and culled away during development. And I wonder if that has something to do with language development and associating sounds to meaning, to especially meaning in the visual world of experience, like a dog is a visual thing that we experience, and the sound it makes is perhaps associated. So the second argument is that there's less domain specificity during infancy. The cortical regions are far less specialized during infancy, and in particular, may respond more strongly to multiple sensory modalities relative to older children or adults. So, for example, a region dedicated towards spoken language may respond more strongly to visual inputs earlier in life. And then the third argument is that the presence of synesthetic like correspondences exists in early life. So 3 and 4 month old infants will orient toward high and pointed shapes when played a high pitched tone, and will orient toward low and rounded shapes when played a low pitched tone. And so these are also it's kind of argued that these might be innate patterns rather than learned patterns. I'm skeptical about that, but I don't know. That might be the case. So this kind of idea that synesthesia might be lost during childhood kind of fits with arguments I made in the Phoenix effect about eidetic memory and phonetic sensitivity. So basically, eidetic memory is photographic memory, and we observe this almost exclusively in very young children. And so there's arguments that this is also lost in favor of more efficient forms of memory. So in early life, you could imagine that we might not have a sense of the world enough for anything except this kind of photographic memory. And our brain may be processing the world in much more depth because we don't have ways to abstract yet. We don't have ways to reduce and simplify our senses into something more two-dimensional or more symbolic or more pattern-based, because we haven't yet realized that we can do that. And so as we learn that we can just kind of like say we learn language, this might facilitate a kind of memory process where we just simply kind of encode our experiences into basically a narrative, a sentence that is like, I went to the store, I grabbed this list of food, and then we might pay much less attention to the video experience that we've had. And you could imagine that that would be a lot of energy being wasted by remembering every detail of every aisle we went down in the store or something like that. And so we might remember the symbol of picking up like beans or whatever, rather than remembering the specific three-dimensional shape that a can of beans might take on. And so yeah, so it's much more efficient if we just kind of learn more simplistic ways of remembering things. So that might be why adults are almost never seen to have photographic memory. But that again is something that people have argued happens in autism or savantism, especially. And so then there is phonetic sensitivity. This gets more interesting. So, phonetic sensitivity, by this, what I mean is children tend to not discriminate between foreign languages, the sounds that are made within languages. So, like in English, if I say the word talk, this has phonemes in it. It has t, it has ah, and then it has k, talk, right? But in other languages than English, there are phonemes that are not present in English. So there's, I think there was one that is between R and L or something like that in one of the Asian languages. So that is arguably where, like, certain, what is the word? Accents come, like if people try to learn English later in life, they might develop an accent. And I think one of them for one of the Asian languages is a mix up of R and L because their language doesn't distinguish it the same or something like this. So, but anyway, so with children, they respond. They are able to hear all of the different phonetic sounds, but then as we grow, we tend to only hear the ones that were reinforced by our own language, essentially. So this is where it gets interesting because we can actually test if psychedelics bring back a phonetic sensitivity. We can like test this and see if, and that could be arguably a higher state of consciousness, that it's increasing the detail of our experience, the richness of our subjective experience, bringing back all the different details of experience that we've kind of culled away because they're so irrelevant to our adult life. Okay, so let's move into Savantism. This gets kind of interesting. I've seen an interview. I don't know if it was legitimate, to be honest. It was a kind of a weird website, but they seemed to interview that researcher Brogard that I mentioned, and he kind of talks about how people gain uh, super normal abilities after like a concussion, like enhanced mathematic ability or music ability or memory or something like that. And this is often called savantism. It also occurs in people that are labeled autistic. Like if you've seen the movie Rain Man, this is kind of the case. He has some extraordinary ability. And I haven't seen the movie, to be honest. I just know that everyone always brings up that Rain Man is a savant. So if you've seen that, that might help you in understanding what savantism is supposed to be. So photographic memory is one of the kind of savant skills that are often mentioned. Um, so it is more common in autism. And so there's this guy named Daniel Tammet, who's a kind of famous savant autistic, and he has synesthesia. Um, so he was able to recite 22,000 digits of pi, which is completely absurd, right? 22,000 numbers of pi. And so in some interview, and I found this in a Nature blog post, they talked about how he was interviewed for The Guardian. And what Daniel explained is, so I'm just going to quote him. When I multiply numbers together, I see two shapes. The image starts to change and evolve, and a third shape emerges. That is the answer. It's mental imagery. It's like maths without having to think. So he claims that his form of synesthesia allows him to do math and deal with numbers using shapes. It's quite fascinating. And this even sounds quite psychedelic. I feel like it's possible that people on psychedelics might have experienced something like that. They maybe just don't recognize it as something actually useful. And so it'd be kind of interesting if it's possible that some of the weirder sensory experiences and ways of processing life on these compounds are maybe they are actually useful. And the thing with savantism is it often comes with deficits, like someone will have photographic memory but fail at something else, like maybe abstract thinking or something like that. It's often like an extreme, heightened ability at something very specific, but a problem with something else. Like someone could just be having amnesia of some sort in another way. Okay, so with psychedelics and learning and memory, DMT was recently found in a 2020 study to enhance learning and memory and also neurogenesis. And that's kind of interesting because DMT is thought to be endogenous. The evidence isn't that great for it yet. It is found endogenously in rats and seems to increase during hypoxic events like uh, cardiac arrest. And that's kind of interesting because there's also evidence that DMT is protective under the case of hypoxia. So it might have some kind of function. And not only that, monoamine oxidase only functions in the presence of oxygen. So if you're having hypoxia, so like one of the arguments is that this monoamine oxidase is too highly prevalent in our tissue to allow any amount of DMT to realistically activate our brain, activate our receptors and stuff. That it would be too weak. But if you were to take something like if you were to inhibit monoamine oxidase or stop its function, it might allow for DMT to accumulate and actually reach levels that are effective. So during hypoxia, this might be what's going on. It might not even necessarily be an abnormal release of DMT. It might just be the sudden failure of monoamine oxidase. So, monoamine oxidase only works in the presence of oxygen. That is kind of what the whole oxidase part of this is. So, there's kind of research on that I've done a post called Getting High, which is basically about altitude, low oxygen, and like breathing techniques, like the Wim Hof method you might have heard of. People try to change their state of mind by breathing differently. There is also, what is it? some breathing method that I can't exactly remember right now, but let's kind of move on. Okay, so there's kind of mixed evidence though with the psychedelics. There is psilocin has impaired acquisition, learning basically in a high dose, and the high dose even impaired retrieval of memory in rats. But another study found that psilocybin, they showed enhanced fear extinction learning that was dose dependent and occurred in the low doses. So it's possible that when you go too high, something else happens. And it would be interesting if, like, so one of my kind of potentially unsubstantiated hypotheses, it kind of even fits with all this stuff. It's that what if we don't remember early life because it's such an extremely different mental context that we are not in that state of mind so much that we just don't access those memories. Like maybe they exist, but we just can't access them. So like if you've heard of context dependent memory, if we listen to music while we study for a test, it's argued that if we listen to the same exact music while we take the test, the memory would be more associated to that music. It would kind of trigger that memory. And so I I kind of have argued in the past that we kind of have a background context for which our memories are easily associated to in our adult life, that we at first in life we might be building this context. We're building a kind of background music for our daily life. And it might be kind of just our baseline reality. And we might kind of cling on to this baseline reality where we start associating everything to this grounding level of our reality where kind of just the everythingness associates to it. So it might be that early life doesn't have that. It also might be that the state induced by these states, like say you take a psychedelic, it might take you to such a drastically different state of mind that your normal state of mind is not a cue that triggers the retrieval of those memories. It might be so different that you struggle to remember any of that. But then maybe if you go back to those states of mind, you might recall everything. And so I think that it's possible that people that take psychedelics are reaching infantile states of mind and remembering some of those memories, which might be completely unrecognizable to what we're used to experiencing. So, like, say you recall a whole videographic experience that happened during infanthood, and it's just nothing like what you would experience in vision today. Like you would, like the way you process your vision is different, the way you process sound, everything. Your whole memory might be synesthetic, for example, and you would maybe people would assume that this is like maybe you'd even misinterpret what that was, because it's not like when you were an infant, it's not like you had interpretation. It's not like you realized you're an infant. It's not like you realize that you might not even realize that a person is your mom, although there's evidence supposedly that people do recognize their mom early. But you might not recognize objects. You don't have object permanence in these memories. So the way you process reality might be completely alien. And so I think it's possible that people recall that. And I think we could test that if if we get people into these like far out alien states, give them a specific experience and try to somehow record, like get them talking on video about those experiences, and then maybe we could like play it back to them or try to bring back that memory, have them retrieve it the next time they are in such a state, and see if they can like maybe we will only cue that memory with something specific. We'll have a series of objects, like maybe toys or cubes or like random objects, and have them associate that memory, like distinctly have them present the object, make them put that into their memory, and then redo the exact, like, here's the objects. Do you remember? What do you remember? Like, first we can try what do you remember to see if they'll bring it back. And then, yeah, so anyways, I'm kind of losing the train of thought there. But we could basically test that, and we can see how much they remember, and we could try to especially look for memories that they do not recall very much when they are not in that state. So that was like way off. But anyways, so there's memory, there's fear extinction, learning enhancement. There was dose dependent with psilocybin. There's MDMA, enhanced associative and non-associative learning in rabbits. So this is where it gets weird. MDMA enhanced plasticity with repeated neurotoxic doses. But it's possible that the neurotoxicity is a different mechanism. But it's worth mentioning because some of the learning mechanisms are actually also neurotoxic mechanisms, like the NMDA receptor, glutamate receptor, or whatever. So MDMA also showed enhanced fear extinction. LSD was found to enhance associative learning in rabbits. There was a news study that mentioned that LSD acutely enhances BDNF, which is related to plasticity and learning. So it's kind of a lot of things that we could get into with learning and memory. But I think I'm going to try to move on for the purpose of brevity. So something I'm like super curious of is basically the idea of that maybe psychedelics can induce savantism. I've argued that they can induce an enhanced learning and memory. And the evidence of that is basically like synaptogenesis, plasticity, neurogenesis, the observation of enhanced learning and memory in animals. And I basically argue that it's disrupting dynorphin and kind of loops of dynorphin that exist in the brain. And dynorphin's anti-plastic. It is anti-learning, anti-memory. It blocks NMDA receptors, which are involved in plasticity and learning and all this. And basically it is, I argue that it's like dissociative and involved in schizophrenia and stuff like that. Okay, so we're pretty close to the end. Could kind of get into, I think music is synesthetic. I think that the way that it elicits emotions, if you play a major chord, it seems to give you happy emotions. That could be synesthesia as well. It could be a auditory to emotion, or temporal auditory to emotion synesthetic thing. And that might have something to do with the way that our vocalizations are intended to, or we have like these expressions, like I'm modulating my voice up and down. If you hear an infant cry, it elicits in emotions. If you hear someone scream, it's like a ah, right? So it's like a descending sound. And so there might be all these different things that elicit emotions, and maybe music somehow exploits these. I'm a little bit skeptical, but something to think about is there's this speech to music illusion. So like I'll show you right now. There's a speech to music illusion. There's a speech to music illusion. There is a speech to music illusion. There is a speech to music illusion. There is a speech to music illusion. Now that probably sounds really weird now. So if I kind of get back into that again and tell you about how there is a speech to music illusion, now that probably sounds totally strange. It sounds like I maybe saying that one little part of the sentence. I could do it again. Like I sang that one little part of the sentence. Like I sang that one little part of the sentence. Like I sang that one little part of the sentence. Like I sang that one little part of the sentence. So you can kind of tell that you really notice the modulations of pitch in the context of repetition. So it could be that music is designed to completely exploit our sensitivity of noticing emotional expression in pitch changes, in rhythm, and different things like this. And that those are usually applied to what is it? What was I saying? I'm losing my train of thought. It's usually applied to vocalizing and speaking to communicate emotion. And we might not even be that conscious of it. I'm not that conscious of my pitch modulation. I'm not paying attention to what is supposed to mean. But perhaps music completely elucidates that world of perception. And so dance is kind of another kind of music. If you think about it, it relies on repetition. It relies on kind of the synesthesia of your video, your like visual, your movements, the way you appear to synchronize to the music. So this is kind of like you're trying to synesthetically express the music to other people. Oh, my voice. My mouth is so dry, so it's like changing my voice. So I think I'll kind of, okay, so something that's interesting is I think that the reason the repetition is important here for music is that I think it's the complexity of things in speech. Like the melody of speech is so entirely complex that it is just not able to be tracked like how music is. And so, for example, if you take an auditory signal and ramp up the complexity and you keep doing that, you eventually hit a point where it starts to sound like white noise. It's just like that sound right now is an increasingly complex sound. And it's probably like my teeth, all the little shapes and stuff like that is creating something too complex, like outlining maybe all the different subtle cracks and ridges and like shapes going along the edges of my teeth is like creating too many different waveforms that your brain is just now, it is just like one sound that is incomprehensible. And so like I do like music production, and you can kind of see this when you're doing synthesis, or even if you were to layer tons of instruments, it eventually becomes like noise. You just hear static. And so I think speech is closer to the domain of noise. It is closer to the domain of chaos. And the lack of repetition, I think we just can't process that level of detail But if you repeat it, I think there's like a learning mechanism in short-term memory or something like that, where the repetitions kind of start to amplify the level of meaning that you can experience in those sounds. You start to notice all the nuanced parts of the sounds. And it's kind of interesting because so one of my other projects right before this was called Musicalization. And it argues that psychedelics musicalize all of our senses and perception and cognitions. And by that, I mean that this kind of repetition thing that's going on, I think we would require less repetitions before things start to musicalize and develop meaning. And so, like, people on psychedelics will kind of hear things as musical sometimes. Sometimes, like, the sound of a faucet running suddenly sounds like, or like water drops dripping onto the metal at the bottom of the bath. It will kind of sounds like do 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 do. You kind of like begin to hear melodicness to it, and people's voices might sound more melodic, or you might notice the synchronicities of events. Like if people are talking while they walk, like if I say, "Hi, I am talking," or just the word, let's say that just the word talking, t, k, ging, like those are the consonant parts, right? You might notice that every time they step, it synchronizes with a consonant or something like talking or whatever. So, like, kind of becomes rhythmic and musical. But also, the reason I think that is that repetitious stimuli seems to produce the same exact kind of effects that we observe on these compounds. So, for example, there's like this video where you stare at a spiral that just keeps repetitiously moving like this, and if you stare at it without moving your eyes and not blinking too much, it when you look away, your walls will do the melt. They'll melt. They'll be moving. They'll be like growing and changing size, and so we know that that happens with repetitious stimuli. And people talk about the walls breathing on things like psilocybin. And what if it is actually your own breathing and subtle moving in and out is doing, it's like creating a motion effect strongly enough that the walls are like doing that, just like that video. Like maybe instead of 40 seconds of repetition, you need like one or two. And maybe when people are talking, you don't need them to loop for you to notice the nuance and detail and acuity of melody and rhythm in their speech. Instead, you notice it's without repetition. And another thing is if you stare at the wall, you can kind of get some of the same changes to vision. So, yeah, okay, I'm going to stop it there. And so I'm curious, any of you have memories from childhood, from really early childhood? I've read a little bit about people who've claimed they can remember being born. That's like far out. I'm really skeptical. But do any of you remember your experience of the world being like psychedelics during childhood? If so, please comment below. I would love to hear about your experiences. And please follow and subscribe, whatever. Like the video. I wonder if that actually works when people say it, but I mean, it probably does. It reminds people that they are able to do it, I guess. But yeah. Hope you're having a good day, and see ya.